This is what we learned from 6.1. I just want to give a quick review. And what these letters are. This is a formula that we use quite extensively. Finance, we use it for loans, for business. Okay, we haven't hit the logarithms just yet. We'll be doing logarithms within the next day or so. Let me have a show of hands. How many people will not be here on Wednesday? There's a trip to the DIA. Ooh, all right. Okay. The A stands for the total amount. What is something worth? What is your investment going to be worth after a number of years? What is your I don't know, if maybe you have a classic car. Well, what's it worth? What's it going to be worth? What was it worth a few years ago? All right. P stands for the principal. And this is the amount that you start with, your base amount. I mean, maybe it's a population growth. You've heard that term for a while there. Livingston County was growing exponentially. Growing exponentially. Livingston County was. It was the fastest growing county in Michigan. Heartland has grown exponentially in the time that I've been here. But it's amount that we start with. And that's what the P stands for. The 1, well, you can think of that as being 100%. All right, but it's just a number that's built into the formula. R is the rate. The rate is given as a percent, but for figuring purposes, we have to use decimals, as you guys probably saw, right, when you were doing your homework. Now, the rate is also called, different vocab here, the effective yield. They ask you to find what is the effective yield. I'll give an example of that in a minute. They're asking you to find the rate. It's very warm in here today. I don't think the air conditioning is working. They don't allow us to open the windows.
This year is like first and second hour were pretty cold.
Really?
Well, maybe the heat is turning on, and that's why.
Maybe. And then T. T is time. It can be in years. It can be in months. It can be in seconds, minutes, centuries, decades, just depending what we're talking about. All right? We're going to be talking about years for time, but it doesn't have to be years. So that's what all those numbers stand for. Okay? All right. So let's talk about investments for a minute. Let's say that you have very nice grandparents, and you guys are going to be graduating in a couple of years. And grandma comes over and says, I want to give you a present. And I want to give you $10,000. All right? Now, because you guys are all smart, you've got your scholarship to this big university, so you don't need the money. You don't need a new car because your parents bought you a brand new car for graduation, right? Because that's usually what parents do.
No.
See, and then your parents can watch this video and say, well, I guess that's what parents do.
Oh, yeah.
All right. So you want to invest your money. So along comes this guy and says, well, I can give you 6% interest compounded yearly, every year. 6% interest. Now, you don't need this money for a while. You're going through college, you get a job. You don't need this money until you hit 30 years old. You decide to get married, buy a house. I'm going to use this money, okay? How much money will you have when you turn 30? I'm going to guess that most of you are 16, so let's say in 14 years. So we're going to take the money that we start with, $10,000, 1 plus, and the interest rate we set was 6%, right? And we're going to leave it in there for 14 years. And how much money we have. Now you guys did probably something similar to that on your homework. You go to your calculator, $10,000 times 1 plus 0.06. By the way, what is the 1.06? What is that called? Do you remember? Multiplier. The 1.06 is the multiplier. Okay? And then we want to raise that to the 14th power. So after 14 years, by the way, this is compounded every year, meaning at the end of the year, they're going to give you the interest on $10,000. At 6%, you'll have $10,600 at 1 year. At the second year, they're going to give you 6% of not 10,000. You're not going to make another 600. You're going to make 6% of 10,600. So you're getting interest now on your interest. That's what compound interest means. All right, so this is compounded every year. You're going to have $22,609.04. And that's compounded every year or annually. So you've a little bit more than doubled your money. But what if a bank says, well, you know what? We can compound your money semi-annually. What does semi-annually mean? Twice a year, right? Every 6 months. So what they're going to do is they're going to figure out your interest after 6 months, not after a year. And then another 6 months, they're going to figure out your interest again. So every 6 months instead of every year. Now, without putting that stuff in your calculator, we need a little bit different formula, and that's what we're talking about today. The formula is going to look like this. And we have a new variable involved here. And the new variable is n. And what does n stand for? N is the number of times that your money, number of times compounded per year. So it's a number of times compounded per year. Okay? Now, without putting this into your calculator, what is your best guess for how much money? If it's compounded annually, you're going to make $22,600. Compounded semi-annually, what's your best guess? What do you think, Sean?
I just have a question.
Yeah.
Why wouldn't you just double the amount of, like, instead of 14, put 28, because then just do it as a number?
Oh, because it's not for 28 years. Remember, this is years, the number of years. Not the times compounded. 14 is the number of years. T is in time, which is in years. So we're not going to put it in there for 28 years. What do you think? Give me a guess. It's going to be more.
40,000.
40,000? Okay, let's just see. So, using this formula, it's going to be 10,000 times 1 plus 0.06 over 2 raised to the 2 times 14. And then it will be 28, Michelle. Okay? So 2 times 14 is 28. So go into your calculator. 10 times 1 plus 0.06 divided by 2 raised. Now, if you're going to put 2 times 14, and you're going to put that in your calculator, you need to put your exponent in parentheses. 2 times 14. Okay? Otherwise, it's going to square it and then multiply by 14. You're going to get all the stuff. It's more. $22,879.28. So not as much as what you might think. Okay? Not as much as you might think. And the reason why is because we're dividing the rate by 2, and we're doubling the years, but it's more. Not that much more. And this is why you have to be educated on your investments, on loans, money that you borrow, money that you put in. So, but it is a little bit more. It's another $270. Okay. If it is compounded quarterly, what does n become? 4. Compounded monthly, n is 12. How about this? You're going to see some banks that give you daily interest. And maybe you've seen that in ads, maybe you've seen that on billboards outside of banks. By the way, have you ever seen a rundown bank? Have you ever seen a bank with a broken window or it's been all run down and needs a coat of paint? No, I haven't. No, they're all making money. All right, they're all making money. Is the bank going to give you this kind of interest rate on your savings? 6%? What is it? Anybody have a savings account? What is the interest rate on your savings account? I think it's about 0.7% or 0.8%. It's less than 1%. Why is that? Because when I was your age, banks would be giving 4, 5% interest rate. It doesn't make sense. Why? How come back then they were giving 4 and 5%? What do you think, Michelle?
People had less money.
Yeah, people didn't have less money. Relatively speaking, the value of the dollar has changed, but people still had the same amount to invest. Not the same amount, but relatively the same amount. What do you think?
They weren't as smart back then.
Oh, no. Like I say, you never see any poor banks. Well, when you decide to put your $10,000 in the bank, they take that $10,000, among other things, and they loan it out to other people. Maybe somebody needs $10,000 to buy a car. And so the interest rate that they're charging now for a car might be 2.5%, 3%. So the money that they're giving you, 0.7%, they're charging, they lend it out at 3% maybe. Well, back then, they're giving me 4%. But back then, if you wanted a car loan, you'd be paying 10%, 11%, 12% on a car loan. And mortgages were up around 13, 14%. So everything is relative. That's why it was different. Well, let's check out daily interest. Daily interest, what changes here? 365. And instead of 2 times 14, it's 365 times 14. Okay? So we're going to take our $10,000 times 1 plus 0.06 divided by 365 raised to the, now you gotta use parentheses, 365 times 14. Again, it's more money, but maybe not as much more as you think. Okay? But it's compounded more. And there's always something called, there's something called continuous interest, which is something we'll get to later on in the chapter. So it goes from annually 22,609 to compounded daily at 23,160. So another $500 or so compounded daily. What would make your investment go up quicker? I mean, obviously, if you had more money invested, it would go up quicker, or if you left it in there longer. But what makes the biggest difference, you think? The percent. It's the percent. Take a higher percent every time if you're going to save and invest. Okay. Most times. Okay. So that's our new formula that we have. One of the problems you had in your homework on that worksheet, I don't know if any of you guys watch Mecum. It's called Mecum Auto Auctions. It's on the Speed Channel or something on cable. All right, but they have these classic cars that people bid on. And there was a car like mine, like my classic car, and I wanted to see what it would go for. And I think a car like mine went for, I think, $42,000. Okay. Now, back when that car was new, it was the most expensive car that Ford built. The most expensive car that Ford built that year in 1958. And the cost for a car like mine would be $3,200. But over time, it becomes a classic car, it becomes antique, now it becomes more in demand. And so now that car is worth $42,000. Let's just say that right now, and I don't know this to be true or not, but let's just say that right now it grows exponentially by 3% per year. So my multiplier is 1.03. Okay. Now I bought this car 6 years ago. How much should that car have cost 6 years ago, growing at that rate? What do you put in for time? A negative number. You don't change anything else, but you change the time, and we're going to put that to the -6. Okay? And that will tell you. So if I put that in a calculator at 42,000 times 1 plus 0.03, which is my multiplier, raised to -6 power. So maybe 6 years ago, that car could have been sold for $35,000. That's a good increase of 3%. I don't know if that's true or not. All right? How much, here's a question for you. Back in the 90s, 80s and 90s, the rule of thumb was if you wanted to invest your money, the rule was it's a decent investment if your money doubles every 10 years. So if you put $5,000 in the bank, not a bank, but if you invest your $5,000, in 10 years you'll have $10,000. In 10 more years you'll have $20,000. In 10 more years you'll have $40,000. So it doubles every 10 years. What interest rate would guarantee that? In other words, what is the effective yield? Let's figure it out. What is the effective yield if we invest? It doesn't matter how much money we invest. Um, let's say let's take our $10,000. I want to know what the interest rate is if it doubles every 10 years. Well, what is the A? What would that be? What would the amount be? 20,000, right? 20,000 equals 10,000 times 1 plus r raised to the 10th power. I want to find out what the effective yield is when you see this term. Divide both sides by 10,000. And I would have 1 plus r raised to the 10th power equals what? 2. See, it didn't matter how much money we invested. Somebody said $12. Well, if somebody put 12 here, your amount would be 24. 24 divided by 12, it would still equal 2 over there. So it's still the same amount. Okay? How do we solve that for R? Talk to me. Could you do it if it was 1 plus R squared? What would you do then? Square root. So let's take the 10th root. Take the 10th root. And how do we take the 10th root of 2? I could take 2 to the 1/10th power. Remember, the bottom number is the root. I could take 2 to the 0.1 power. 0.1 is 1/10. I could do this in your calculator. Hit 10 first in your calculator. Go to your math program. Scroll down to the x root. Enter on that, number 5. That's a 10th root of 2. And so I would get 1.07177 equals 1 plus r. We're looking for r, which is the effective yield. So I'll subtract 1 from each side. And I get 0.07177. And what is that percentage? 7.2. So if you can invest your money, and a financial planner, financial advisor tells you that we can get 7.2, the history of our company has been we can give 7.2% per year. Will double your money every 10 years. That's our effective yield. Does that make sense? Yes? Yeah, Michelle.
Wait, so is the effective yield term just for the double thing or for anything where you
For anything. It might say how many, yeah, it could be for anything. Okay? Effective yield. Okay. Homework. Page 367 and 368. 10 to 28 even. 29 to 34 all. 47 to 53 all. That's your homework.